This Earth and Space investigation is based off the Stage 3 syllabus. Today we're looking at the best materials for making a levee along a river in times of flooding. Our testable question is, what happens to floodwater when we change the material of the levee? A levee is a device that we construct to be an effective barrier against flowing water in the event of a flood. These are usually made out of sand. Our aim in today's experiment is to find out what other materials might work as an effective levee against flowing water.
The dependent variable in this investigation, or the variable which the scientist is trying to investigate, is the volume of water that makes it through the barrier. This should be collected and measured in milliliters. However, I was unable to for this experiment, so we are analysing our results through visual means. Our independent variable, which the scientist deliberately changes, is the material of the levee. This will change for each repetition of the experiment to find out which one works best. And our control variables, or the ones that stay the same with each experiment, are the volume of water that is poured into the tank to simulate river flow, the amount of time the levee is left, and the flow rate at which the water is emitted from the hose. This flow rate was the same for each material where the hose was on full blast and pointed at the same place in the tank.
First of all, we make a prediction. I predict that the materials with more density and salinity will be more effective as a levee against floodwater. The first material that we're going to use is pebbles. We're going to try and see if these pebbles make an effective levee against flowing water in the event of a flood. I'm going to chuck some pebbles in a bucket. Once we take our pebbles over to our experiment area, we can start. This fish tank that we're going to use will simulate the flowing water of a flood. Once we load our pebbles into our fish tank, we can make a levee out of these pebbles. We're going to prop up one side of our fish tank with a plank of wood. This is so we can simulate flowing water and not just still water. And now we bring on the hose. Look closely and see what happens when we fill one side of the fish tank with water. Oh no, it doesn't look like it's working at all, does it? If we have a look closely, the pebbles haven't been an effective barrier at all. They've let all the water through to the other side. Now that we've emptied our fish tank, we can try with a different material. Our next material is planks of wood. We're going to try and stop the water from a flood with our planks of wood here. We've got a plank of wood that fits inside our fish tank, however the issue is that there is a huge gap. So we're going to use a different plank of wood and try and fill that gap. And here's our wooden levee. Time for the hose again. Watching this experiment, it doesn't seem like the wood is doing a very effective job. But if you look closely, it's actually pooling on the first side of our barrier, meaning that it's at least stopping the water for a little while before it seeps through the gaps. The end result of this plank of wood experiment is not looking good. Our third material is soil, just soil from the garden. We're going to pile it into a bucket again and then make a really solid barrier out of our soil to try and stop our floodwater. Here we have our soil barrier. Here comes the hose. Wow, look at that! It's stopping the water completely. There's not a single drop getting past the other side. Look at that! All the water is pooling on the right-hand side of our barrier, meaning that it's stopped the water completely. Our soil is a very good levee. Until this happens. Since soil absorbs water, it's inevitable that a little bit will seep through, and eventually, if you leave it for long enough, it will pull through the other side completely. But for now, it's doing a great job. Our fourth and final material is plastic. We're using a general plastic bag from the supermarket. We're going to cut it up so we can have a long strip of plastic to use as our levee. Once we tape it inside our fish tank, we're going to see if it works. All taped up, we've tried to stop all the gaps with packaging tape. Let's see how it works. Fourth and final try for the hose. look at that, it's actually working pretty well. For a little bit. The water does seem to be coming through very, very slowly, but for the majority, the water is actually staying on the right-hand side of our levee. Meaning if we were to plug this up a little bit better, it would actually work as a really good levee. If you leave it for long enough in this state though, it doesn't work very well. Time for our results and analysis. Since this is a stage 3 experiment, numerical data is better than just a visual depiction of the results. However, since numerical data is harder to come by in this context, we will be using pictures to analyse our results. The pebbles were not an effective barrier. Almost immediately after the water hit our makeshift levee, the water started pouring through to the other side, meaning that our pebble levee was almost useless. Let's see if the next material worked. Our wooden barrier was only a tiny bit more effective than the pebbles. Although the wood is a more solid substance and it was able to temporarily stop the flow of water, there were too many gaps on either side of the barrier to effectively stop it completely. This means that if we were to try and stop floodwater with wooden planks, it wouldn't work very well unless we were able to plug up the tiny gaps that would inevitably occur. Soil was a much more effective levee. Once the water hit our soil barrier, we could see the soil getting drenched, but not a drop of water actually made it through to the other side. It was packed tightly enough to not get swept away in the current, so if we were to make a levee out of this material, it would work pretty well. At least for a while. Our last material was plastic. Although the plastic itself worked as an effective barrier, the issue was similar to our wooden blocks experiment earlier on. The substance itself would be able to stop the water, but the inevitable little gaps that appear, even when you try and seal them, will eventually let all the water through. Conclusions. Soil was our best material by far. It stopped the water almost completely. Our next runners-up were wood and plastic, and these materials worked for a few seconds, but the water eventually spilled through the gaps. The only material that didn't work in the slightest was pebbles, unsurprisingly. The pebbles immediately let the water pour through due to their generally round shape and being unable to seal closely with their neighbouring pebbles. And that's the end of our experiment.